In this video, we're going to show an improvement that we've made to our height plane system. So when I open this up here, we'll open up the pocket. You can see that we now have under Z heights category, we have clearance, rapid, feed, start cutting, and end cutting height. And then the column to the right of that, we have offsets. So these are just basically values that you can enter in that represent our clearance plane, our rapid plane, and so on and so forth. And then to the right of that, or we can also open this up here, we have another value for each height plane that says relative to, okay? And that's kind of the new feature here. So when I drop this down, we can see that we have a whole bunch of options here, and I'll go into details on all of these here. But essentially, we get to pick where our different planes are going to be relative to. So let's show this graphically a little bit. Let's just look at the clearance plane for now. If I click on clearance, you can see that in our graphics over here, it shows up and tells us where our clearance plane is. And then we'll turn on our stock workpiece, and you can see that we're, 100 thousandths above our starting stock. Okay, so if I change this to 0, our clearance plane should now be directly on top of our starting stock. All right. And so let's go ahead and change this. Let's change from the starting stock. Now we're going to change our clearance to our model. Okay, so that is going to drop the clearance plane down to the top of the model. It's kind of like the extent, the highest point that it can find on the model. And then again, we still have an offset from there. So let's just go ahead and put a big number in there so we can see what that does. We'll say 1 inch above is going to be our new clearance plane. And so now our clearance plane is exactly 1 inch off of this top surface, which is the model, okay? So that kind of demonstrates how one of the height planes works. And these all work the same exact concept. They're just all different values and different heights that the machine will traverse to when it's actually operating the toolpath. So let's look at a couple of these here. Let's kind of explain what all these different clearance or the different height planes are. So the clearance plane is the plane that is used by the machine to go over to the pocket, and then when it's done the pocket, to get away from the cutting area. And let's go ahead and actually create a toolpath so we can see what this looks like here. We'll just grab a 1/4 inch tool. I'm not sure what it would be best to use there, but for demonstration purposes, this will be fine. Okay, so if I click on my clearance plane, you can see that we have a couple of locations that it's going to go to up there at the top. And what we can do is simulate our toolpath, and you can see that it's going over to this at our clearance plane, and then it'll just start cutting from there. And then it should only go back to that clearance plane at the very end of the toolpath when it's getting out of the way, right? So there we go, it's going up to our clearance plane there. Okay, our rapid plane is down lower typically, and this is the plane that it's going to use kind of internally inside of the pocket routine when it has to go up and then transition over to continue, say, a different area of the pocket. Okay, so that's kind of in the middle of the actual pocketing routine. Our feed plane is how high it's going to go. Is our height plane for when it transitions from our rapid move to our cutting feed rate. So after it's done a rapid move anywhere in the pocket to a new location, it's then going to rapid down to the feed plane and then feed between the feed plane and the start cutting height. Okay, and our start cutting height is where it's basically going to start to spiral down into the pocket, and then our end cutting height is where it's going to finally finish. So in the past, we've always had similar options to this, but the nice thing about these new 5 options is these are very standard for any one of the instructions, right? So before we kind of had different ways of handling all the different heights, and now this is all unified. So everything basically works the same. So once you understand the heights system for a pocket, you'll understand it for a profile or an etch instruction or any of the other instructions. Okay, so Let's go ahead and talk a little bit more about the different relative to options here. I talked a little bit about starting stock and model. So I'll just move on to origin. Origin is essentially like an absolute Z offset from the origin, which is going to be our world coordinate system right there. Okay, that is typically not a very good way it's typically not a good idea to use origin, because if you ever change anything in your model, so you move your model up or down, or if you just move a face around or anything like that, this is there's nothing to update because your value is kind of an absolute value from your origin. But if you use something like, say, I don't know, say the stock workpiece, right, like your starting stock here, then we're going to always be relative to our starting stock. So if we increase our starting stock and add, say, 100,000s onto the top of our starting stock, your rapid plane or anything that's relative to the starting stock is going to move along with that. It's called a parametric relationship. And that's always really handy. Okay, so now model in chain. Okay, so that's similar to model. That's going to go off of the model, but what it does is it finds just the portion of the model that is close to the chain. So it kind of makes like an XY box out of the size of your chain, or the area that it's going to cut after it's been chained, and then it looks for the highest Z in that area. So that helps in cases where you might have a big part of the model somewhere else that's really tall, but you're trying to work in somewhere that's lower. Let me actually bring up a model that shows that a little bit better. Okay, so here's another model I just brought in to demonstrate this. So you can see we have these higher Z's over here on the left side of the part, and it would be okay if we wanted to cut this, and every time it has to transition from one area of the pocket to the next, if it went all the way up to clear the whole part of the model. But since we're just working in this localized area over here, it never really has to go up that high. So if you have, like, say, your rapid height set to model in chain, you can see that it kind of takes an area that's close to the size of the box that you can see graphically here, and it uses that as your height. So let's change this to 0 so we can see exactly where it decides it's going to put it. So if I kind of look down the side here, you can see it is right on top of this face right here. So the software has determined that this is close enough to our chain, or maybe even inside of our chain or directly on top of the chain, that it's going to want to bring the Z up high enough to clear this every time. Okay, so that's a big help. And then you kind of always want to make it a little bit higher, so we say 100,000ths away from this height value here. Okay, and what this says here, okay, so after well, let's just go down the list here. We'll get to the next height and previous height here in a second. So selected geometry. So another way that we can handle, let's just say that in our rapid move here, we want it to go all the way up to, say, this height. Okay, so we want to clear this for whatever reason. Then I can come over here and say select geometry selection, and then click on this height. And now we're going to be 100,000ths relative to that selection. Okay, so we can select any area that we want to set any of our rapid planes relative to. And let's see, I guess we skipped over selected chains. Let's go ahead and click on that. And what that is the chain that I selected. So I kind of skipped over that. What I selected here was this triangular shape face there. So our rapid plane is now going to be directly on top of that face that I selected. Usually not very useful for rapid, but it is useful for, like, say, the end cutting height. We can change this to 1 inch, and you can see what that's going to do. It's going to now be, it's going to rapid 1 inch away from our selected chain. Okay, so that's going to be way up there. Okay. So what else here? So we pretty much talked about all these. So previous height and next height. Let's drop down here to the feed, because it makes a lot of sense when using your feed and next height. So what this says is the next height after the feed is actually our start cutting height. Okay, so it's going to take whatever our start cutting height is and it's going to rapid 5 thousandths away from our start cutting height. Okay, so, and this feed location will always update even if we change our start cutting height. So let's do a direct right view here so we can see it's going to start spiraling in over here. You can kind of see where it starts to spiral in. It goes off to the right there, and the Z starts to traverse down. But this is going to wrap it to 5 thousandths away from that. If I change this to 0, yeah, see now it's going to wrap it all the way down and start to go from there. So let's change this back to 5. And now what I can do is if I change my start cutting height to, say, add an extra 25 thousandths onto there, now you can see that not only has our start cutting height increased, but our feed height has also increased because the feed is always relative to the next height, which happens to be the start cutting height. All right. And previous height works exactly the same way, except it uses the height previous to that. So let's say that you wanted to come over here to our end cutting height. And instead of going all the way down to the selected chain, if we just want to cut down, say, I don't know, 100 thousandths from our start cutting height, right? So now we know that from wherever it starts cutting, we're only going to cut down 100 thousandths from there. And so, yes, that's pretty cool. Okay, so now let's look at a rough solid. Okay, so this is more advanced than the pocket routine. It's kind of actually just a series of pockets working their way down in Z. So here we have really very similar options, but instead of start cutting and ending height, we just call these top clipping plane and bottom clipping plane. And so what that means is between the top clipping plane and the bottom clipping plane is the area that you want to do, you want to perform pockets in. So I won't go into too many more details about rough solid. We'll just specifically talk about the height planes here. And the most common way to use this is to set both of these to work relative to the model. So the top clipping plane is going to work relative to the model. And just one more option here I haven't talked about yet. It's going to work off of the top of the model. Okay? And the bottom clipping plane is also going to work off of the model. It's just going to be the bottom of the model. So it's basically going to cut everything from the top to the bottom of the model and everything in between. And since both of these are 0, we know it's going to just, there's no offset, it's just exactly on the top and the bottom of the model. Now if I wanted to say, okay, I want to go all the way down to the model, except I want to leave 3/4 of an inch, I just change that to positive 3/4. And then you can see that our bottom clearance has moved up, or sorry, our bottom clipping plane has moved up 3/4 of an inch. And then if I recompute that, you can see it's now only going to go down to there. Okay? So let's look at one more nice usage of this. We can come over here to our model and change this to geometry selection, which I talked a little bit about earlier. And then I can click on that bottom plane down there. And we want to make sure we change that to 0 offset from that bottom plane. And now you can see that our bottom plane, instead of being off of the very bottom of the model, it's now on that plane that I selected. Right? Okay, now real quick, let's talk about surface finishing. So a file like this, the only kind of unique thing to surface finishing is there's really no Z level as far as like an end cutting height or start cutting height or anything like that, because you're cutting a surface, right? So the Z is constantly changing. So the way that the planes are handled in here is a little bit different. And probably the biggest difference would be the feed plane and the way that's handled. So right now you can see we're 25 thousandths away from the next height. Okay, well the next height isn't really the start cutting height. The start cutting height is kind of the same thing as a clipping plane, how we showed in the rough solid, but instead it's where it's going to find the surface. So you can see we're rapiding down to 25 thousandths away from where it's actually going to start cutting. If I change this to 50, you'll see what's going to happen there. It just doubles that. So it rapids down and then feeds down 50 thousandths before it starts to cut, which is probably the most common use of the feed plane. But sometimes you want to actually, let's say you're hogging out the whole material and you don't just have to cut 50 thousandths off of that surface there. So you kind of, in that case, you're using it kind of like a roughing routine. you could say we're going to start at the model. Okay, so now that's not relative to where it starts to cut. Now it's always going to jump back up to our model for our feed plane. Okay, and actually probably even more common than model, you would just go all the way up to the starting stock, right? Yeah, so let's turn the starting stock on so we can see it, and you can see that it's now going to transition exactly from where the starting stock is. Okay, and that's going to be absolute regardless of where, you know, how far down the surface is that you're cutting. If it's really close to the starting stock or way down low, it's always going to feed from that top starting stock. Okay, and then one more here we'll talk about is etch. Etch is really very similar to everything else, like the pocket and the profile, except we've always controlled independently the outline for etch and the inner pocket. So here we just have two separate depths, and these are kind of like the end cutting. They both start from the start cutting height, and they cut down to the pocket depth. That's for kind of the inside here, and the profile depth, which is the top profile up here. So yeah, so that you can control those independently is the important takeaway here. Okay. Oops, I meant to go negative 0.05. Okay, something like that. Okay, so one more that we'll talk about, and then I think we're done here, would be pin stop. And this is very similar to basically all the other ones, except there's not 5. We only need 3 height planes here. So we're going to first wrap it over to the clearance, and then wrap it down to the feed plane, and then finish feed down to end cutting. And it looks like in this case here we have our end cutting set higher. So let's just change our end cutting down to, say, negative quarter of an inch, something like that. Yeah, okay, so yeah, so for anyone that doesn't know, this is just there's no cutting that happens in pin stop. It's just the machine just basically moves over to this location, and you would typically use like a solid bar, like a solid round, you know, piece of steel or something like that, and then you can push your part up against it in a vise rather than picking up 0 on your part. So it's kind of a fast way to just locate your material into like a vise commonly. Yeah, so we switched that over to the new height plane system also. Okay, so I guess that pretty much covers it. Thanks.